Excellent. Sorry for the delay. Today, we are going to start section 4.1. We're going to get through about 4 sections of chapter 4. We'll get you to do some coding and we'll go from there. The first section is this thing called increment and decrement operators. They're shortcuts. Again, we have some more what we're calling operators. Well, one of the things that you use a million times is going to be num equals num plus 1. Okay. And if we're going to do this for plus, we can use num equals num minus 1. All right. Now, a shortcut for this, a shortcut is to take this operator and, instead of an equal assignment operator, instead of a plus operator, we're going to rewrite it as num plus plus. Okay. It's the same thing. It adds 1. Num minus subtracts 1. But this guy right here, starting in this chapter, we're going to use him a lot to add 1. Okay. Now, we have this, it's called an overloaded operator, but we keep getting operators over and over and over. There's actually another one that goes with it that almost nobody uses, but we better learn what it is, and it's this one. But they are different. This is what's called a post increment. This is called a pre-increment. Post is after, pre is before. So I'm going to look at a little block of code. I'm going to say x equals 6, y equals 7. And if I'm going to hand trace them, I'm going to say, hey, x is 6, y is 7. Then I'm going to say my next line is going to be y equals x plus plus. Now, what's the value for each of these? Well, after the first line, x is 6. After the second line, y is 7. After the third line, it's read this way. Y is assigned the value of x, and then it's incremented. So y is assigned the value of x. Y gets the value of x. Then x is incremented. Ew.
So y is not equal to 7. Only x is equal to 7.
Y is going to get the value of x.
Uh,
Currently, x is 6. So y gets this value 6. Then I'm going to take x itself and increment. So this is the same as y equals x equals x plus 1 in that order.
oh, okay. So when you print it, you get the both value. You get the y value and x value.
They're both going to change. And if I do it again, x equals 6 and y equals 7. Now I say y equals plus plus x. I come over here. I have x and I have y. When it comes to this line, it's going to, let's see, we start out with the values of 6 and 7 again. It comes in and says assign, but first I need to increment. So this is now going to become 7 because I'm going to increment first, then assign it to y. This becomes 7. And this time it's the same as x equals x plus 1, y equals x. Okay, they're reversed. We're not going to do this very often. We're going to do this bad boy right here. But I wanted to make sure that you understand there is a difference between these two. If you see it, then you might go, hey, yeah, okay. Again, this is the one we're going to use most of the time. All right. So moving right along in chapter 4, starting with section 4.2, we're going to get into something called looping. And looping is repeating a block of code. There's going to be times where we come into the program and we need that if statement. Remember with the if statement, we came in, we hit a statement, and then depending on what happened, we either followed a true path or we followed a false path. That was our ifs, our if thens, and so on. So all of a sudden we had a decision to be made. Well, now we're going to get into something called looping. And the way we're going to work is shooby dooby doo. We're coming down in our program. Shooby doo. We hit a block where there's some code going on. Then we hit a decision statement. Something might happen with this decision statement, but we're going to come out and maybe go here. But after that, we're going to go all the way back up and repeat. My other choice is I get out of that repeating process, this looping process, and I keep going with my program. So I'm coming down, shooby doo, boom, 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 and we're out. Okay. So we have a way to come in and we check right away. And depending on what the result is, we're going to do this block of code. So it's going to come down. It may skip this block of code completely. It might not get into this body. Might not get into this body of work that we want to repeat over and over. Okay. This guy is called a pretest because I check before the body. I check before I get into that body. Well, if there's a pretest, I'm willing to bet that if I came over here and I started coming down, shooby dooby doo, here's the body. Now I have a decision statement. I can keep going or I go up and repeat. This is a post test. Okay? We're talking about checking before I get into the body, checking after I was in the body. Over here in the pretest, body may never get executed. So this may, a body runs 0 through an infinite, however many number of times. You notice the body over here, the body runs at least once. Okay. All right. I kind of see the layout. Coming in, may never get into my body. Comes down, hits the body, and then it may loop back around. I have to figure out how I jump up there. But otherwise, I come out and keep going on with the program. Questions? Stay in there. Stay there. All right. How do I control this? Well, there's a way to control this loop. And what we're going to use is a variable to do that. We're going to use a variable to control the loop. Anybody have any idea what that is? What do we call the variable to control the loop?
Bracket.
Look, right here it is. Just say that. That's all. The variable to control the loop is a loop control variable. It's a variable. Okay. All right. So give me an example, sir. Sure. X equals 1. X is less than 9. Remember, this is a decision statement, true or false. X plus plus. Oh, there's that plus plus thing. There's that plus plus. I come in, X is 1. Is it less than 9? Yep. Go execute the body. Hey, I did do that, so I'm going to add 1, and I'm going to come up and do it again, and do it again, and do it again. How many times does this loop run?
Infinite.
How many?
Up to 9.
Oh.
Up to 9. So yeah, this guy runs 8 times. Runs 8 times. Uses my loop control variable to tell me how to keep running. Nice. Nice. X we know is not a very good name. So let's see. My loop control variable, I needed to start somewhere, has an initial value. it has some sort of check, right? It's going to check it. And then it has some sort of update, some sort of increment. We may be counting down, we could decrement, but some sort of increment, for lack of a better word right now. Some sort of increment. How about this one? Counter equals 0. Counter is less than or equal to 10. Counter plus plus. This body runs at least once, may get out after that. This loop runs how many times?
9 or 10. Right?
Careful. If I was to track this, counter becomes 0. I come in and add 1. Counter becomes 1, 2, 3. I keep going as long as it's less than or well, I got these backwards. I totally messed up. Backing it up, backing it up. Here's my decision statement, right? This is where I apologize. Counter is less than or equal to 10. Okay. This is my decision statement, just like here. This is my check. My loop, my increment is going to be inside of here. Counter plus plus. Totally apologize. Now, how many times does this run? 1 is less than or equal to 10. 2 is less than or equal to 10. This guy's going to run 10 times. Starts at 0, but I add 1 right away. This guy over here, this format is the one we're going to use a lot. Okay. 3 parts of the loop. We have a part where we give it an initial value. We have a part where we do the check. We have a part where we do the increment. Initial value, increment, and check. Check, 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 Mike, check, Mike. Check, Mike. Oh, you're funny. I know. Okay, so that was a flow chart. Let's get this into some code. Let's get ready and get some code going. So section 4.2. Oh, geez. Here we go. Section 4.2 is the first one. And here we're creating something called a while loop. A while loop. Now, this is that first one. That was this guy. That was this guy, the pre-test. So I want to make sure I put a note. Runs 0 or more times. Runs 0 or more times. Okay. This was my pre-test. All right. Well, how's it work? Well, this is kind of easy. I'm going to write while counter. This is one I like to use, CTR. While counter is less than or equal to 10, shooby-dooby-doo, I'm going to get the initial value. Counter equals 1. Here is my check. I need the increment yet. Counter plus plus. Ta-da! Here's that body part. It comes down. It may never get in the loop body. It would skip right past it if this is false. Otherwise, it comes in. It does counter plus plus, and it automatically knows to go back up to the while statement.
Just to clarify for myself, this program would run 0 through 9 times potentially.
So counter, we get the value of 1, 2, 3, 4, 5, 6. So now it's 7. That's still true. Now it becomes 8. That's still true. It becomes 9. That's still true. So let's see. It started at 1. We went 2. We're down to 9. It just
I
became
missed the
9.
equal sign.
Yeah, so this is still true. So it'll stay in. It becomes 10. This is still true. So it would come in again, and now counter becomes 11. So this guy would run 10 times. Great question. This guy would run 10 times. Now, if I said right here, output CTR, what value would get outputted?
That would be 11.
Yeah, that would be 11. So when this became 11, this became false, and it moved me on and kept me going on in the program. Yep.
You will print 11 too in the loop.
Well, it'll become 11 right here,
Oh,
but it becomes 11 and comes up, and then this becomes false, and it kicks me out.
so it adds like 10 and 1.
Yep. Yep.
Oh, okay.
Okay. So far, so good. Yeah. I'm going to keep going a little bit. What if I had this loop? Counter equals 10. Yeah. While counter is less than 9. Counter plus plus.
It will not work because
Yes,
10
it'll exactly. Yep, won't work. Well, it'll work. It'll just skip the while loop. It'll never execute the body here. Okay, it never gets in. What if I have this? Counter equals 0 while counter, oh geez, counter is not equal to 9.
So
Counter equals counter plus 2. Counter equals 0. While counter is not equal to 9, I come into my loop.
it will be 10, 10 plus 2, I guess 12.
What happens to this loop? It would be 0, then
It doesn't
2.
get complete,
It
or it's
runs
an
forever.
infinite loop, correct?
Yeah.
Oh.
This is what we call an infinite
Infinite.
loop. And you will get stuck in an infinite loop. Runs.
Sorry, Kashab, I didn't mean to cut you off there. That was rude.
No, you're okay. Everybody's good. Runs forever. It runs forever. It goes on and on and on. Sorry. Sometimes I just think I'm Tayo Cruz. No, I'm just kidding.
I got a question. So after like 9 it becomes the 10, but it's not 0 is not equal to 10, so it will continue going on, right?
Oh, yep. Because we did not equals to. So that's just an example of an infinite loop that runs forever. That's test question. 3 points. Next test. There, whoop, there it is.
If there was a system printout at the end of the bracket, so where you currently have written infinite loop, right? It would print out the 0
Would never
Or-
get there.
because it would never get to the adding 2.
Well, it would go here, and then it would come in the body and add 2, and when it hits here, it would go back up. This isn't in the body, so it would never get to this line. It's just going to stick in here. Got
it.
Yeah. Okay. What do I want you to do? Well, with the paper and pencil in front of you, I would like you to do this. Display the numbers from 1 to 100, 1 to 100 that are divisible by 3 evenly. Ooh. Display the numbers from 1 to 100 that are divisible by 3 evenly. First of all, I need to make sure I understand the problem. And I'm thinking the output should be 3, 6, 9. Shaka Khan, Shaka Khan, Shaka Khan. Just by hand, write that code, see what you come up with. Can you do it using a while loop? You can use a system dot out dot println because we're just doing some pseudocode. When we're learning stuff, we can use the console. That's its advantage. System dot out dot println. Yeah. Bum bum bum. Ba-da-da-dum. I'm going to need an initial value. I'm going to need a check. I'm going to need an increment. I'm going to need, oh boy. As it goes on and on and on. And I like using counter, CTR equals. Apologize for the writing. My handwriting is a little better than this, but I get excited when I'm teaching. Like I've told you guys many times, if I'm going too fast, somebody's got to speak up and say, well, slow down just a minute, slow down. It would be like that is the top. That's a definite option. And you have a modulus going on. Ben likes the idea of a modulus. Got some good work there, Ben. Keep it simple, though. Can you make it a little simpler? Don't overthink it. I said, shoot, shoot, shoot. Uh, counter is 1, while counter is less than 101. That's my check. Counter plus plus. So I'm going from 1 to 100. Okay. If it's divisible by 3, when I do the modulus, my remainder would be 0. So this would, in fact, only print out 3, 6, 9. The goose drank wine. The monkey chewed tobacco on the streetcar line. The line broke. The monkey got choked. Oh, y'all don't know that song. That's an old song. Anybody know that song? Nope.
Unfortunately, I do.
Oh, excellent. That's what I like to hear. Was made famous by a singer named Kia Zadora. How about that?
The artist was very much lost to me, but the song I had.
What do you think about that? I have a question. How many times does this loop run? Counter starts at 1 and goes to
102.
just 100 because this is less than.
Oh yeah.
So it would kick out. So yeah, runs like 100 times. Well, we're now, hang on back. This line right here, system.out.println counter runs 33 times. The rest would run 100. This one 33. Well, no, wait a minute. It's time for us to start thinking outside the box. Is there another way to do this? Oh, yeah. Ben's answer of running 33 times. Check this out. I could have a program without an if statement. So this is 1. I print out 1 times. That gives me 3. Yeah. This now becomes 2. I come up. It print out 6. Nice. 9, 12. A totally different approach. This guy only runs 33 times because I had 33 numbers I wanted to display, not 100. Thinking outside the box, getting kind of creative. That's right. Solution number 2. Let's see what we have here. What? I know. What if I started it at 3, printed out the 3, add 3? This guy would go 3, 6, 9, all the way up to 99. He runs 33 times. Another way to do it.
So you're printing the odd number, right? I mean,
And one's divisible by 3. So it's 3, I print it, I add 3. Comes back up, it's 6 now, I print it, I add 3. So I keep adding 3 each time. Now, what if these two lines were switched? What would be the first number that printed out if these two were switched?
6.
Yeah, yeah. So the order of these is important. You have to be careful. Order matters. The order matters.
So for the last one, like when like the 3 adds to the 3, it gets 6, and it goes like 6 is less than 100, then like it will work like that, right?
I'll print the 6, become 9, goes back up 9. So back in the old days, we used to do a lot of hand tracing, and I'd come in and say, counter is 3. I come in, I print out the 3. Now I add 3 and it's 6. I go back up, it's less than 100, so I print it out, and then I would add 3. And we would hand trace by writing down all of our variables and then putting the values in. We had to be more efficient back then. We didn't just run, run, run. We had to do lots of typing of code, and then just to get it to compile, and then type code to get it to run. And so we had to be really careful, slow down the actual code writing, do a little more thinking.
So after it prints 6, it will go, and 6 is less than 100.
So it would print out the 6,
Yeah.
become 9. 9 is less than 100. It would print out the 9. Now it become 12 because I add 3. Go back up. It's less than 100. Good. Print out to 12.
Oh,
Change counter to 15. So this one went by 1 at a time, and then we had to check. This one's going by 3 at a time.
okay. Thank you.
Sure. Da, 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 da.
Would the third program be easier to run by the CPU because there's less decision making?
Well, the second two would be, yes, because there's less decision making. The first one, remember, ran 100 times, plus had an if statement in it.
Would there have been a benefit over the second one or third one?
As far as in the world, where are you? In the world of compiling time, yes, because this runs a third faster than this one would run. We're not looping, may even be faster than that because we're not checking, but we're still doing a calculation.
Yeah, but also with the solution 2 and solution 3, is there one that is better than the other for 2 or 3?
I don't think so.
I didn't think so. I was just checking to see.
Yeah. Yep.
Picking your brain.
Yeah. You're slim pickings. I'm just saying. If I put num plus plus before the lines of code, what would the output be? Yeah, that's one of those. So you're looking at like here, whoops, if here, I come in counter is 1, and then if I had this next, counter would become 2, and the first number I'd print out is 6. So I wouldn't get that 3. I'd have to make some other adjustments inside of here. So that's where order. Same with here. I would have to start it at 0, but then add 1 and yada, 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 yada. So just be careful. This is usually the last thing you want to do, the increment. Code listing 4-3. I do believe you typed this one in. Oh, that's not the right marker I want. 4-3. And I'm now going to holler initial value. Check. Increment. There they are. Nice and smooth. Nice and smooth. You typed in 4.5. Okay. This is now section 4.3. Oh, section 4.3, using the while loop for input validation. Okay, I would like you to enter a number between 1 and 100, and the user inputs -6. What's going to happen to your program? It's going to be wrong, right? It's going to be wrong. It's not a number between 1 and 100. I want to be able to get a number between 1 and 100. So we can use a while loop for what's called input validation. Okay? So here's an example of, other than that basic loop we just saw, what I can use a while loop for. And here we go, soccer listings. All right. Now, nice documentation. Some of you are still lacking on this. This program calculates the number of soccer teams that a youth league may create from the number of players available. Input validation is demonstrated here. Okay, so you type this in, and hopefully you got an idea of, all right, let's see what we got. Get the number of the players on the team, right? This is one of my basic inputs right there. These two are tied together. I input it. It comes in as a string, and I convert it to an integer. Now, I'm going to use this while. So I'm getting an initial value. Team size is my loop control variable. This guy is my loop control variable. And this is my loop up to here. Shaka Khan, Shaka Khan. This is my input section. This is my input section. I get a team size. Now, here's my validate. If team size is less than the minimum number we need, or it's greater than the maximum number we need, okay, so this was my initial value. Here is my check. All right. If it's not, if this is good, right? If we get in and and we're ready to move on, it's going to skip past this loop and come down here. Enter If it's bad, here's what happens. We have a body of this loop. This guy right here is the body of the loop. Down to here, the body. And then I have my increment. Well, this isn't an increment, it's an update. I update my loop control variable. Starts with an initial value. Here's my check. Here's my body. Here's my increment, update, whatever you want to call it. 3 parts of that loop. It's going to stay here until we get something that's good to move on in the program. This is input validation. I like it. So later you're going to have to do input validation. Where is it? We just covered it in the book. Whoop, there it is. We just covered it right there in the book. We come in, the first thing we do is we get a value, we check it. If it's not good, we say, hey, it's not good. And then we get a new value. Nice. I almost wish the author would get his red pen out and a highlighter and do the things I just did, because now it sticks out really nice. And when you come back to this, you're going to be like, oh, yeah, now I got it. This is what I say, Harry Potter and the Half-Blood Prince, where he gets Snape's book and it's all written in and it's old and yucky, but all the stuff is added to it, makes it look easier to read. Does anybody know who Harry Potter and the Half-Blood Prince? Okay, thank
No,
you.
Harry Potter.
I was just Kashab, you got it as well? You're good?
Yeah,
I'm trying to be hip, make a reference. Thanks, Ben. I appreciate that. So section 4.3. Oh, where was that where we used a loop for input validation? I go to the front of the book and I go, hey, where was that? I'm reading down through this guy and it tells me, yeah, oh yeah, in chapter 4 is where I can find it. Yeah, 4 point, yeah, right there, 4.3. I can go and figure out where that input validation is. Okay, questions? All right, so we had lots of work so far. If I had to summarize it all, we had the loop and so forth, and we had. Oh no, wait a minute. If I remember, today we started talking about about. Whoop, where is it? Here it is. We just finished talking about this pre-test, right? Pre-test runs 0 or more times, on and on. Well, let's take a look at the post-test. The post-test comes in section 4.4. Where are you? Here we go. Here we go. Section 4.4. And here we're going to take a look at something that's called a do while loop. Oh, okay. A do while loop. This was the one that was the post test. I came in and hit the body, and then I came in and hit the body, and then I had check me, and then I went out and possibly went back up. Okay, this guy runs at least once. What do I mean by run? Uh, Hits the body of the loop. Okay, it's going to hit this body at least one before I decide, do I do it again or move on? And how do I do it? I do it with this thing called a do while loop. All right, so let's see what we got. An example of a do while loop. Do counter equals 0. Do, what are we going to do? All of this. Ching, 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 ching. While counter is less than 10. That's something I'm going to need in there. I'm missing one thing, aren't I?
An increment.
An increment, yeah. And again, that's usually down here towards the bottom. That's usually down here towards the bottom. So I'm going to come down and I'm going to hit the body at least once before I hit my while, before I check it out. A do while. These guys are locked together. A do while. And we don't use these a lot, but there's specific situations where it does get used. Sorry, got excited. Where it does get used. And I'm looking at this code listing. Okay, we're in this section right here, 4.4, the do while loop. We're in here. And again, I just talked about the do, and then everything is in braces. And we looked at the flow chart. We broke that. We did everything we need there. So now we need an example. Do. Pow. Do. Enter score 1. Enter score 2. And I do some enter score 3. I find the average. Do you notice that this is divided by 3.0? 3.0. So if I said your scores are 0, 0, and 1, what's your average? Well, if you were dividing by 3, 0, 0, and 1 would give you an average of 0. It wouldn't give you an average of 0.33, which is what you want. So we have to remember about that integer, real, or double. How do we want it to be? And of course, average had to be that way as well. Okay, so all that's fine. So I come in and all of a sudden, this is a great use for a do while loop because I just did all this work. I displayed my program. It's nice. And now I'm going to say, hey, user, would you like to do it again? System.out.println. Here's the average. And here we go. System.in. Would you like to average another set of test scores? Enter yes or no. You read in the next line, stored in a string. We get the first char at 0, we know is the first thing, stored in a char. And then here's my while. While repeat equals 0 or repeat, excuse me, while repeat equals the character capital Y or repeat equals the character lowercase y. And if this is true, it's going to go back up to where the do started. Yay, run again option. Say yay. Nobody?
Yay.
Yay. Yay, with great enthusiasm. Yay. All right. We got to type. I talked way too long. You know, I don't like to talk too long. Sometimes I am a long talker, but I need you to now write this program. I'm just going to put you in small groups today, not big ones. I want you to write a program to display the numbers from 1 to 10 and their squares. And their square roots. What? I got to make sure I understand the problem. So my first question is, what? Display the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ha! Definitely going to be a loop. How about it? I might even put a title up here, numbers. I want to put their squares. Squares. 1, 4, 9, 16, da 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 da, da all the way to 100. I might want to underline these. And their square roots. One, two, three, four. That's a 2. What's the square root of 2? That's like one of these is 1.414 or something like that. But print out all of their square roots, all the way down to whatever the square root of 10 is. 3 point blah 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 blah. 9 is 3. Yeah, I know that one. Got it? Starting to think, print this heading line. Print this heading line. Have a loop go from 1 to 10. Then work on this part. Then work on this part.